Good morning, dear students. Yesterday, what we studied, that is stopping set distance we studied, isn't it? We'll just brief out this stopping set distance. Okay, what is that? It is the distance required to stop the vehicle. Okay, it is the distance required to stop the vehicle. So that is called a stopping sign distance. Again, it is depends upon the various factors. It is goes with the vehicle, it is goes with the friction, it is goes with the age of the vehicle, characteristics of the vehicle, and the gradient of the vehicle. All those things. These are the factors which are going to influence the stopping side distance. Okay. Now again afterwards we have studied about the reaction time and the perception time. Again this is directly related to your PIEv theory. PIEv theory, that is called as perception, intellection, emotion and volition. Okay, PIEv theory. So we'll study here about this PIEv theory. So what is perception time? It is the time required for the sensation received by the eyes or ears of the driver to be transmitted to the brain through the nervous system and spinal cord, or it is the time required to perceive an object or a situation. First, you think that you are driving one vehicle. Suddenly you have seen a stop or any object on your road, isn't it? So now you want to stop the vehicle, isn't it? What is that? You want to stop the vehicle. This concept is completely based on that. You are in that situation. Think that you are in such situation. Perception is the when you are going to see the object. Okay, so through how you are going to see? You are going to see through the eyes, or you can hear it. Can hear the sound. Eyes or the ears. These are what? Sensations. Sensation. Okay. At the moment when you are going to see, you need time. It is in terms of microseconds or in terms of seconds. Okay. You need time to pass this sensation to your brain. To pass this sensation from your eyes or ears to the brain through nervous system or a spinal cord. Nervous system or through a spinal cord. Whatever the time required to transfer the sensation from your eye or ear to the brain, that time is called as perception time. That time is called as what? Perception time. Let's move to the next, that is intellection time. Intellection time is the time required for the driver to understand the situation. To understand the situation, it is also the time required for comparing the different thoughts. Okay, so when you are going to see, initially what happens, your eyes are going to see and that message has been transferred to your brain through the nervous system. That is called perception. When the message has been reached to the mind start working. Start working, whether how to stop and whatever the different thoughts, whatever the possibilities are there, that mind will take time for comparing the thoughts, and that time period, comparing and coming to the conclusion, that time period is called as intellection time. That time period is called as intellection time. Third one is emotion time. Is the time elapsed during emotional, sensational and other mental disturbances such as fear, anger or any other emotional feeling, superstition, etc. That means when you are going to see this has been message has been transferred to the brain, that is perception. In brain it's going to think the possibilities, and comes to the conclusion that is in intellection time. When you are going to feel it, at the time you are going to have some sensation either that is in terms of fear, anger, all those things. That is called as emotion time. That time is called as emotion time. Next, last one is the volition time. Volition time is the time required by the driver for the final action, such as brake application. Volition is the time, it is the time required for the action. What? This is for the final action, such as brake application, isn't it? So you can see here in the figure, stimulus means when you are going to see the object, that point is, it is stimulus. Response, stimulus and a response. Response is the whatever action taken by the driver, that is response. From the stimulus, the message has to be passed through the brain. Okay, here this is your brain. In brain, what happens? Intellections happens and emotion happens. What happens in the brain? Intellection and emotion. In intellection, driver understanding the situation and he will think that different possibility, and he will have some emotional replies. Okay, that is emotion and interaction that will be there in your brain. Okay, afterwards whatever the action he will take, that will be in the from the brain, it is, that is volition time. Okay, that is your response. This is the PIEV theory: stimulus, intellection and emotion, then volition. From the brain again it is in the reaction. This is action process taking place, this is the reaction. That's it. This is PIEV theory. Understood? Now the stopping side distance depends upon the speed of the vehicle. In the previous video lecture also I have explained that this stopping side distance depends upon the speed of the vehicle. Okay, as the speed is more, it requires more distance to stop the vehicle. It is as usual. Okay, when the speed is more, you require more time to stop the vehicle. Okay, so that side distance is going to be increased. If the speed of the vehicle is more, stopping side distance will also be more. If the speed of the vehicle is less, stopping side distance will be less. Next, again it is depends upon the efficiency of the brakes. Again, if the efficiency means, it depends upon the vehicle, what kind of vehicle it is, whether it is a new vehicle, whether it is old vehicle, and also it depends upon the characteristics of the vehicle. So whether it is having a normal brake system or hydraulic brake system or air brake system or a disc brake system. Okay, you are having those ideas, isn't it? Okay, so what kind of brake system it is there, it is depends upon that also. If the brakes efficiency is 100%, means the vehicle will stop at the moment when the brakes are going to be applied. If the brake efficiency 100 means the vehicle is going to be stopped at the moment when the brakes are going to be applied. Actually, in practically it is not possible to achieve 100% brake efficiency. Next, this stopping side distance and also again depends upon the frictional resistance between the tire and the road. It depends upon frictional resistance between the tire and the road. The frictional resistance between the tire and road plays an important role to bring the vehicles to stop. When the friction resistance is more, the vehicle stop immediately. Thus, site required will be less. No separate provisions for brake efficiency is provided while computing the side distance. that only when the frictional resistance between the tire and the vehicle is more, the vehicle stop immediately. Thus the side distance required will be less. No separate provision for a brake efficiency is provided while computing the side distance. This is there. Next is analysis of stopping side distance. Now whatever you have studied the theory, now we will have to calculate the stopping side distance. How to calculate? So lag distance means the distance taken by the vehicles to stop the vehicle. The distance taken by the vehicles to stop. If v is the velocity and t is the time taken to stop the vehicle, then your lag distance is equal to v into t. If v is the velocity of the vehicle and t is the time required to stop the vehicle, then your lag distance is equal to v into t. So is your velocity is in terms of, let us assume it is in terms of meter per second, and time is also in terms of seconds. So seconds numerator and the denominator get cancelled, so you are left with the what? Distance, meter. Oh, that is your lag distance. Similarly, if your vehicle is having a design speed of kmph, kmph means kilometer per hour. Your vehicle is having a speed of v times kilometer per hour, so many kilometers. What it means? It is per hour, so many kilometers. And distance is in terms of what? Time taken to stop the vehicle. It requires some, it takes some distance to stop the vehicle, but the time elapsed to stop the vehicle, that distance is t. That will be there in terms of seconds. So your velocity is in terms of speed, design speed is in terms of kilometer per hour. That you need to convert in terms of meter per second. That you need to convert it for meter per second. So kilometer to meter you just multiply with 1000. Kilometer to meter you just multiply with 1000. So this lag distance is equal to Vt, isn't it? To convert it from kilometer to meter, it is just multiply with 1000. Now it is in terms of meter per hour now, but your time is in terms of seconds. So 1 hour means how many seconds? It is 60 into 60 seconds. So then divided it by 60 into 60. So that's equal to 0.278 v into t. So the whatever the lag distance you are getting in terms of meters, or it is 0.28 vt. V in terms of kilometer per hour and t is in terms of seconds. We will get the lag distance. Clear here? Shall I explain once again? Here v is the velocity of the vehicle, t is the time elapsed to stop the vehicle. So our lag distance is equal to v into t. Let us consider an example. V is in terms of meter per second, time elapsed is also in terms of second, so it is meter per second into second get cancelled, so left with meter. That is distance, lag distance it is. Okay. Similarly, but in our actual problem, your vehicle is moving with a design speed of v kilometer per hour. It is in terms of what? V kilometer per hour. And t is always in terms of, it is a small time duration, so it is always in terms of seconds. Time elapsed will be very less, so it is in terms of seconds. So here is one parameter is in terms of kilometer per hour, one is in the terms of seconds. So it should be what? In terms of seconds. So kilometer is there, we will convert it in terms of meters. So multiply with 1000. So it is Vt into 1000. It is per hour is there, but what we need in terms of seconds we need. So to get in terms of seconds, we will have to divide it by 16 to 60. So it is Vt into 1000 divided by 16 to 60. So that's equal to 0.278 Vt, that is nearly equal to 0.28 V into T. Here V is in terms of kilometer per hour, T is in terms of seconds. No need to convert the velocity of V in terms of meter per second. You directly substitute the value of V as in terms of kilometer per hour in this formula to get the lag distance or stopping side distance. Next is the braking distance. It's the distance traveled by the vehicle during the braking operation. When brake has been applied, the distance traveled by the vehicle is called as braking distance. For a level road, this obtained by equation work done in stopping the vehicle and kinetic energy of the vehicle. If F is the maximum frictional force developed and the braking distance is 1 inch, then work done then work done against friction is stopping the vehicle is F into L. So it is F into W into L, where W is the total weight of the vehicle. So kinetic energy of the design, kinetic energy is the design speed is half mv square equal to half m equal to wv square by g. So it is wv square by 2g. So half mv square equal to what? F wl. So your L is equal to v square by 2g f. So your L is equal to what? V square by 2g f. Therefore stopping side distance is equal to lag distance plus braking distance. It is lag distance plus braking distance. Our lag distance will be what? Vt plus braking distance is v square by 2g f. Here v is in terms of meter per second, that is design speed of the vehicle. T is in terms of reaction time, that is in terms of seconds. G is acceleration due to gravity or coefficient of friction. The coefficient of friction F is given for various speed of the vehicles. Okay, as the speed will be vary, the frictional resistance between the vehicle and the tire is also vary. So for design speed less than 30 kmph, the frictional is F at F equal to 0.4. If your design speed is more than 40 km per hour, then your acceleration friction is 0.38. If your vehicle is at speed of 50, then the friction is 0.37. If your design speed is at 60 kmph, then your friction is 0.36. If your design speed is above 80, then your friction is 0.35. Again, it depends upon the gradient. If it is in upper gradients, require less distance to stop the vehicle, but that is when it is downward gradient, it requires more distance to stop the vehicle. So based on that, when there is an ascending gradient of say n% plus 10%, the component of gravity adds to the braking action, hence the braking distance is what? Decreases. The component of gravity action parallel to the surface which adds to the braking force is equal to W sin alpha, that is equal to W tan alpha, that is equal to W into N. Equation for kinetic energy and the work done. This will study in next class, because I don't want to put you with heavy these things. We'll study in the next class next time.